I decided to turn this into a three-way proportion question. So the number of gardeners, 4 in this case, the amount of time, 4 hours, to dig 4 circular flower beds, each of diameter 4. So I'm going to work on the area here. That's really what I'm interested in, the amount of area that they're doing in a certain amount of time. So for 4 circular flower beds, each of diameter 4, the radius is going to be 2. Pi times the radius squared gives me 4 pi. That's the area of one flower bed. So if there's 4 of them, the area would be 16 pi. So basically, 4 gardeners managed to dig or an area of 16 pi in 4 hours. And what I'm trying to get to is how long it takes 6 gardeners to dig 6 circular flower beds. Okay, that means the radius is now 3. Pi times 3 squared is 9 pi. And if there's 6 of them, it's going to be 54 pi. Okay, I've set this up. I just need to carefully modify these. So I could, for example, halve the number of gardeners, and then it would double the amount of time that it would take them to do the same area. Times by 2 divided by 2, because the number of gardeners is going to be inversely proportional to the amount of time. Now I'm going to times the number of gardeners by 3 to get to 6. I could have times by 1.5 straight away. I was just taking it slow. So times the number of gardeners by 3, which means I can divide the amount of time by 3 for the same area. And what I managed to do is get the number of gardeners to 6. I'm not going to do anything to that left-hand column now. I'm just going to think about how I can modify the area. So I could halve the area now to 8 pi. Actually, let me just put it down here, 8 pi, and that would have the amount of time that that would be needed for the 6 gardeners. I'm trying to find something that I can multiply by to get 54. So I'm going to keep going. What if I halve it again? That'll take me to 2/3. Now 4 still doesn't go into 54. So halve it again, and I probably should have just divided by 8 right at the start, and I'm going to, in fact, go back and do that just because of space. So if I divide through by 8 to get to 2 pi, it would take 1/3 of an hour for the 6 gardeners. Right, now I'm nearly there. 2's into 54 go 27. So what I can do is, yeah, get 54 pi by timesing by 27, but then I'm going to have to do 1/3 times 27. That's going to give me 9. And that's going to be the amount of time it's going to take for the 6 gardeners to dig 54 pi, which is equivalent to the 6 circular flower beds of 6, diameter 6. It's going to take 9 hours. Nice. I'm pretty happy with this method. I'm just going to show you how the official solutions did it. So they recognize that if 4 gardeners are digging 4 circular flower beds, that's equivalent to 1 gardener digging 1 flower bed, and it would take them 4 hours. And then looking at the diameter of both, we can basically find an area scale factor by squaring. It's because we do pi r squared to get the area. So the length scale factor is going to be 6 divided by 4 because the circle is 1.5 times as big, but then the area becomes 1.5 squared times as big. This is because if you had, say, a square of area 1, and then you doubled all of the sides, you'd actually quadruple the area. It was 1 originally, now it becomes 4. The same sort of things happening. The length scale factor is 2, but the area scale factor is 2 squared, or 4. So that is where this comes from here. This area scale factor is 9/4. And what this means is because we've got 6 gardeners then digging 6 circular beds, that's going to be equivalent to 1 gardener digging 1 circular bed. The time taken is going to be 9/4 times as much. So we take our 4, we times it by 9/4, and in the same way or the same answer that I got, it's going to be 9 hours. So yeah, it's a good approach. It avoids the three-way proportion method that I've had to resort to, but both are good.